Imagine a processor that never quite made it out of the shadows. Not a famous canceled chip like Intel's IAPX 432, not a legendary success like the Pentium, but a half-remembered effort inside National Semiconductor with the codename Swordfish. Swordfish was meant to be one of those bold resets, a way for National Semiconductor to stop being just a peripheral name in CPUs and step onto the same stage as Intel and AMD. Today it survives mostly as a footnote, a fragment in old resumes and scattered references rather than a well-documented product. In this short story, we're going to look at what Swordfish was supposed to be, why a company like National bet on it, what seems to have gone wrong, and what this almost processor tells us about how unforgiving the CPU business really is, being clear where the historical record fades out, and we're left with informed guesswork. To understand Swordfish, you have to understand National Semiconductor's identity. For most of its life, National was known for analog components, power management, interface chips, and embedded parts, the glue that made electronic systems actually work. But National never entirely stayed out of CPUs. In the 1980s, it designed the NS32000 family, a clean, 32-bit architecture that some enthusiasts still admire. It had interesting ideas but never escaped niche status, overshadowed by Motorola's 68000 series and the surging x86 world. Later, National's path crossed with the x86 clone movement through its relationship with Cyrix, one of the scrappy challengers nipping at Intel's heels. National eventually acquired Cyrix, inheriting both talent and designs. For a company grounded in analog and support chips, suddenly owning leading-edge CPU expertise was a tempting invitation to think bigger. Swordfish emerged in this context, an attempt to turn that mix of CPU history, Cyrix know-how, and corporate ambition into something that could stand toe-to-toe with the mainstream PC processors of its day. Here the story starts to blur. Swordfish never shipped as a public product, and there's no clean datasheet or launch presentation to point to. What's known comes from fragments: how National positioned its CPU efforts, how Cyrix engineers talked about next-generation designs, and the market they were obviously aiming at. Swordfish appears to have been conceived as a next-generation x86-compatible or closely related high-performance core intended for mainstream desktop and possibly workstation use. In other words, not a tiny embedded controller, not a quirky research chip, but a serious PC-class engine that could, on paper, compete with Intel and AMD. The goals were what you'd expect at the time: higher instructions per clock, aggressive out-of-order execution, deeper pipelines, and better use of cache hierarchies and branch prediction. Fabrication would likely have targeted the same general process generations available to other commercial CPUs of its era, though the specific node and foundry aren't clearly documented. What seems distinct is the design philosophy. Cyrix had a reputation for squeezing respectable performance out of limited die area and power budgets, relying on clever microarchitecture more than brute force transistor counts. Swordfish looks like it was meant to push that approach further. A lean, efficient engine that could punch above its weight class, assuming everything went right in design, validation, and manufacturing. Whether it truly broke new technical ground is hard to verify. What's clearer is that it was meant to be National's serious contender CPU, not just another incremental step. Even if Swordfish had been perfectly executed, the world it was entering was brutal. By the late 1990s and early 2000s, x86 had become a knife fight with very few survivors. Intel towered over the market, with the Pentium, Pentium Pro, and Pentium 2/3 era establishing not just performance leadership, but also ecosystem dominance: compilers, motherboard vendors, OEM relationships, and a marketing machine that turned model numbers into household names. AMD, after years of being dismissed as a second source, was finally breaking through with its own original designs, proving it could out-innovate Intel at times. Around them, other x86 hopefuls, NextGen, IDT's Win chip line, and others, either got acquired, faded into low-end niches, or disappeared. For any new architecture or core to matter, it wasn't enough to be compatible and competitive. You had to be clearly better, reliably available, power-efficient, and cheap enough for PC makers to take a risk. You needed massive validation efforts to ensure every weird corner case in the x86 instruction set behaved correctly, and you had to do all this on tight schedules before your design was obsolete. Swordfish, whatever its internal merits, was being aimed straight into the teeth of that environment. The technical bar was sky high, and the business moat around Intel's position was even higher. When we ask why Swordfish never became a product, we run into silence. There isn't a widely available postmortem from National, no official timeline of delays. So we have to talk in terms of likely factors, grounded in how the company and the industry were moving. One piece of the puzzle is simple priority. As the 1990s turned into the 2000s, National Semiconductor increasingly shifted away from chasing the bleeding edge of PC performance and toward lower power, more specialized markets. Its acquisition and later disposition of Cyrix, and the emergence of the Geo line for thin clients and information appliances, hint at a strategic pivot, away from head-on battles with Intel's fastest chips, toward niches where power and integration mattered more than raw speed. Another likely factor is schedule and cost. High-end x86 cores are brutally expensive to design and validate. If Swordfish slipped behind its intended performance or timing targets, National would have faced the ugly question: do you keep pouring money into a chip that will enter the market already obsolete, or do you cut your losses? There's also the possibility of being overtaken by events. As pieces of National's x86 business were sold, merged, or reoriented, a long-term speculative architecture like Swordfish could easily fall through the cracks. Teams get reassigned, roadmaps get rewritten, and the project slowly transitions from next big thing to nice idea we can't afford. We don't have the internal memos that sealed Swordfish's fate, but the pattern matches other lost CPUs of the era. A technically ambitious design caught between shifting corporate strategy, rising costs, and competitors that simply moved faster. If Swordfish never shipped, does it matter? In a narrow commercial sense, no. There's no benchmark chart with Swordfish on it. No famous overclocking stories. No retro computing hobbyists hunting down rare boards. But as a piece of computing history, Swordfish is a reminder of how many efforts it takes to build a CPU ecosystem, and how many of those efforts fail quietly. Every successful processor generation sits on top of competing ideas that never made it, design teams that were disbanded, and companies that couldn't quite cross the gap from ambition to execution. For National Semiconductor, Swordfish marked the last gasp of the idea that it might stand alongside Intel and AMD in performance PCs. After that era, National doubled down on what it did best: analog, power, and mixed signal parts, eventually becoming attractive enough in that niche to be acquired by Texas Instruments in 2011. The lesson isn't just don't fight Intel. It's that in a mature, capital-intensive market like CPUs, technical talent and a clever microarchitecture aren't enough. You need staggering resources, unwavering corporate commitment, and the willingness to absorb several near misses along the way. Swordfish, like many vaporware and near-vaporware chips, survives mostly in the negative space of what didn't happen. Remembering it, even through incomplete, somewhat speculative reconstruction, helps us see the complexity behind the processors that did ship, and appreciate how close the industry came to being shaped by projects that almost were, but never quite arrived.